Petrovic, Nenad Petrovic. Please.
Hello?
Okay, can you?
Okay, can you see my screen? Okay. Can you hear me?
Yeah.
Okay. Greetings, everyone. Dear ICES 2022 conference participants, I'm Nenad Petrovic, a teaching assistant from the Faculty of Electronic Engineering, University of Niš, Serbia, from the Department of Computer Science. And now I'll present you my paper, which is entitled COVID-19 Prevention Systems within Hardware and Software Design Computer Science Courses. So the main purpose of this paper is to investigate how we can incorporate exercises that are actually related to COVID-19 pandemic within computer science courses. As case studies, two courses from Faculty of Electronic Engineering, Department of Computer Science track are actually considered. The first one are actually Intelligent Information Systems course, and the second is Microcontroller Programming. In the case of first one, we have the topics which are covering Java Enterprise Edition technology for aiming development of business information systems with several elements of business analytics where we use Weka API for that purpose. On the other side, the main focus of the second course, Microcontroller Programming, is actually design of hardware embedded systems leveraging microcontrollers. And one of the topics which is actually covered by this paper is actually PIC 16 family microcontroller together with RTOS based system using CCS C compiler. So now here are several more details regarding the curriculum of both courses. When it comes to Intelligent Information Systems course, we have this set of technologies covered. So first, the students actually have to develop a database schema for MySQL database, which will actually be mapped to Java objects, making use of object to relational mapping in Hibernate. For this purpose, we rely on Java Persistence API that will actually provide a like standardization interface to Hibernate that actually further can map Java objects to MySQL tables. Actually, to be precise, each object will correspond to row, while each of the attributes will be one of the columns in the table. Moreover, we have Enterprise Java Beans layer, which implements business logic like processing data, executing some business rules, performing calculations, and it also interacts with microservices. In our case, it's Docker technology, which actually deploys the so-called containers. And inside this container, we have Weka API-based machine learning prediction service, as we'll see, like vaccination demand prediction or a COVID test outcome in our case in this paper. And finally, we have Java Server Faces web application, which is like end user interface, and also the client application running web browser, where a user has interface and can input new data or see the results of processing. And once the system is created, or during the development, students are also actually needed to write unit tests using JUnit technology for Java and to perform verification for implemented functions. So on the other side, for microcontroller programming course, we have two main topics. The first one is 8086 Intel-based systems, which is not covered by this paper, but the focus is put here instead on PIC 16F84A, which is a microcontroller widely adopted. And it has 8-bit data memory, 12-bit instructions, 1 kilobyte of flash memory locations for storage of programs. On the other side, we have also EPROM. Apart from RAM locations, we have 60 EPROM locations. Moreover, there are 2 ports for communication with external environment using the so-called ports, and 4 possible interrupt sources timer 0 internal timer,
Sopra
external
no?
interrupt B0, and B4 to
Ja
B7 pins.
se ja završim, brata, motivac kao
Like in addition to this topic, we also integrate RTOS using C compiler for this microcontroller. And on the right-hand side, you can see typical structure of RTOS program. So here, the idea is
dobro da si bide sve kako što treba se
to periodically and as a response to real-time events, or actually for purpose of processing.
Please stop. Please stop.
Like
Dear colleague, please stop. The attenders should be switched.
Počnemo malko ponovno pravim po planetu, pogledamo pauzu malko.
Alexander, can you mute, please?
Please. Okay, can you start?
Okay, and we have tasks which are executed periodically, and we put two parameters for defining these tasks as C functions without arguments and return value. Rate after how much time the task is actually periodically executed, and maximum duration of task within each of the functions. So this is the skeleton of the code. We have tasks which are executed periodically after a given time, and in the main function we run RTOS. Here is the first case study regarding the Intelligent Information Systems course. It's publicly available on GitHub, the source code, and this is an example of a user interface. So the purpose of this application is actually a healthcare information system which aims to support efficient storage and management of COVID-19 testing and vaccination processes. So as a support, we can input data, we can take a look on the outcomes of COVID-19 tests, or input vaccination records for some person. This is this page is implemented using Java Server Faces technology, and the data here visualized is actually retrieved from MySQL database. Moreover, here is an overview of business logic layer implementation on the upper part of this slide. This is an illustration of architecture using example of vaccination records. So we have so-called enterprise Java bin classes. First, we have interfaces, the so-called service classes. On the other side, we have service implementations classes which implement such interfaces. Moreover, Java Server Faces leverages managed bin controllers that actually use these objects which are interacting with database, like vaccination record in this case. And finally, also these enterprise Java bin services, which are the crucial part of business logic, make use of Weka classes that provide machine learning capabilities. And on the other side, JUnit tests are used for unit testing, and they are we ask students to structure them as follows. We have preconditions, something that has to be fulfilled before executing the test, steps which are actually the steps taken within this procedure, where we want to see if some functionality works properly, some function or a class, and post condition, what has to afterwards. So here we first check if there is no test record for some person. In the test case, we update the outcome of the test record, and finally in the post condition, we update the outcome by using the negative value, and finally we check whether the change is visible in the database, whether it's negative. When it comes to Docker microservice interaction, PHP, or in our case, Weka code is actually run within the container, and we interact with it from business layer logic using HTTP requests and forwarding URL parameters needed for predictions, like the day and the outcome. The HTTP response would be the number of persons, for example, interested in vaccination. When it comes to business intelligence layer, we make use of Waikato environment for knowledge analysis, and it's a collection of free tools for data analytics and visualization using under GNU public license. and this is one of the reasons why we selected. It provides a wide set of supervised and non-supervised machine learning algorithms. Here we focus only on supervised learning in this course, mainly on classification and regression. This is the overall workflow machine learning pipeline of Weka, illustrated here on this slide. In the first step, we load CSV file or some other file with data that is used later for training. Once we prepare the data, we have a set of, once we load the data, we have a set of instances in Java. These are Weka classes. We select what is the label for each of the instances, what is the predicted outcome. We perform the training for a particular model. We can use, for example, decision table or decision tree or KNN for classification, or linear regression for numerical outcome, which is not categorical. Once we finish training, we perform evaluation and see how well this algorithm performs. For classification, it can be accuracy, like a percentage of correctly classified examples. For regression, it's like mean relative error. We can then finally apply the model on the previously unseen data once we have it trained and evaluated, and it can be leveraged by a business logic layer. Here are some of the evaluation results regarding the business intelligence part of the case study. There were two cases. The first one is vaccine demand prediction, which is a regression problem. We predict numerical outcome, how many people are actually interested in vaccination for a given day. The inputs are day, vaccination type, vaccine time, and number of cases of COVID cases that day. And the performance was quite high for regression. In this case, like 3% of mean relative error, and training took 6.7 seconds. On the other side, we have classification example for categorical outcome. The best algorithm was decision table. In this case, we make use of temperatures, saturation, and if person is vaccinated, like saturation, oxygen saturation, and the outcome is positive or negative. And accuracy was 78%, and a training time was 5.1 seconds. And this is actually used in Docker container, like we make HTTP request, and then we update the outcome of test, like simulating some random process which can occur in nature. But here we use prediction to see if person is potentially actually infected. On the other side, when it comes to another course, microcontroller programming, we have a design of embedded system, which is actually a control unit of indoor COVID-19 indoor safety multifunctional device. It makes use of PIC16 based microcontroller and CCS RTOS implementation. The device has three distinct working modes. In the first state, it can check if person which arrives has body temperature which is normal, and green certificate which is valid vaccination certificate. In the second case, only the check of green certificate is performed, and the third mode is which is done twice a second, is checking whether our quality is fine. In the first mode, it performs the check periodically each second. And these are three pins used as input. RA0 is temperature pin, RA1 is green certificate, it would be 1 if it's valid, 0 otherwise, and RA2 if our quality is satisfiable. All of these concepts are all actually mentioned in some of my previous works on IoT systems, which illustrate realistic use cases. This is the simulation in Proteus environment and the block scheme of the system. We have PIC microcontroller. We have this button that changes the device mode. These are the input pins, like temperature, COVID certificate, and our quality check. And this is the number of persons inside inside the room. If we have like number of persons which is greater than allowed, then we won't allow anyone to enter anymore, despite the fact that person passes the checks. Otherwise, the person won't be able to enter. Like this number is increased when the doors are open. And on the other side, this other RTOS function is actually performing error quality check, like taking the value of input RA2, and if it's 1, then we'll show 1 here and no LED will be turned on, but otherwise, if our quality is convenient for COVID-19 to spread, it will turn red LED
Please
on.
finish for 2 minutes.
Okay. Okay, and this is the main function where we actually initialize the interrupt that changes the mode. And okay, just to quickly mention, this RTOS task checks if person passes COVID-19 measures, like in the first mode, state 1, whether both temperature and green certificate are valid. And in the second state, it only checks if green certificate is valid. And if the number of persons currently is lower than max allowed people, then this number will increase. And quickly, just to see the simulation, how it works, like if we have in the first mode that the number of, that both checks are passed, it will increase the count of persons on the screen. Otherwise, once we have that the maximum number is reached, it's 6 in this case, it won't increase anymore. But for our air quality, you can see if it's 0, it will turn the red light on. And finally, these are the evaluations regarding the outcomes of the both courses. For both courses, we had increase of involvement when we integrated these exercises within lab exams and practical projects that students have to implement as part of pre-exam obligations. They actually shown that adoption of such exercises was effective in both courses, but a bit more effective in microcomputer systems, actually microcontroller programming course, as it also involved some additional exercises like bonus points that are actually able to be changed for written exam. And students were really motivated to do such exercises. One of them was this exercise. And in this paper, it was shown that adoption of such exercises on pandemic topic actually motivates students to be more active when it comes to both participation in lab sessions and other additional activities, and also some slightly higher exam pass rate, which was as outcome of this as a consequence. Taking all the consideration, microcontroller programming course was a bit more suitable for this case, but both courses shown satisfiable results and motivating that actually show that even computer engineers and other engineers have very important role in global battle against this pandemic. Thank you for your attention.
Please, any questions? Can I ask something? When you talk about real-time system,
yeah, it was
okay, you have 3 types: hard, soft, and firm. What kind is your system?